Good day, everyone. Welcome to another video episode for Senior High School STEM. The aim of this tutorial is to help grade 12 students in understanding the topics in general chemistry. So get ready to learn. Take a deep breath, have an open mind, and think that chemistry is easy and fun.
Today's discussion is about the self-learning package for General Chemistry 2, Quarter 1, Week 3, Physical Properties of Solution. This self-learning package is published by the Department of Education, Schools, Division of Iloilo. Concentration of solutions. Concentration expressions are often based on the number of moles of one or more components of a solution. The three most commonly used are molarity, mole fraction, and molality. We start with mole fraction, which has the formula of mole fraction of component is equal to moles of component divided by total moles of all components. Remember that the two components of a solution are solute and solvent. So this component could be solute and or solvent. Total moles of all components would be the moles of solute plus the moles of solvent. So mole fraction of solute is equal to moles of solute divided by moles of solute plus mole of solvent, while mole fraction of solvent is equal to moles of solvent divided by moles of solute plus moles of solvent. If the number of moles are not given, this is the formula to be used. Mole of a substance or component is equal to the mass of the component in grams divided by the molar mass of the component in grams per mole. Grams per mole is the unit for the molar mass. Let's try sample problem number 1. What is the mole fraction of the solute in a 40% biomass ethanol C2H6O solution in water? Remember, we need to write first the given, the required, and the formula, followed by the solution. Okay? So, given, we have 40% by mass ethanol. Ethanol is also known as ethyl alcohol. And then we need to solve for the molar mass. It is not given here, so we need to solve it here. So if you write this molar mass in the solution or in the given, either way is correct. So, molar mass. How do we solve for molar mass? Remember that molar mass is simply the formula mass expressed in gram per mole. Formula mass has a unit of AMU. We remove or replace AMU with grams per mole. Okay, so how do we solve for the molar mass? So ethanol can also be expressed as C2H5OH. The OH represent the functional group of alcohol in which ethanol belongs to, because ethanol, as we said earlier, it is ethyl alcohol. So identify first the elements present: carbon, hydrogen, oxygen, and the number of atoms. Carbon have 2, hydrogen 5 plus 1, 6, oxygen 1. And then from your periodic table, the get the atomic mass of carbon, that is 12 or 12.01. But here we'll just round it off. Later in college, if your teacher wants to have it expressed in decimal points, then do so. Okay, it's up to your teacher. But for now, we will use the rounded off atomic mass for convenience. Hydrogen has an atomic mass of 1, oxygen 15.99, we rounded off to 16. Okay, so we'll multiply 2 times 12, 24, 6 times 1, 6. 1 times 16 is 16. Total is 46. So instead of AMU, because we are talking about molar mass, this will become gram per mole, or 46 gram of ethanol per 1 mole of ethanol, or 1 mole of ethanol over 46 gram of ethanol. Okay, water, H2O, elements present, H and O. There are 2 hydrogen, 1 oxygen. Hydrogen has an atomic mass of 1. Oxygen has an atomic mass of 16. Multiply 2, 16, add 18 grams per mole. Okay, required mole fraction of solute. Here, what is the mole fraction of the solute? Formula: mole fraction of solute is equal to moles of solute divided by moles of solute plus mole of solvent. Whatever is being required or asked here should be in the numerator. Solute. Okay. Solution. The basis here, because the mass of the solution was not given, we will have the basis of 100 grams of solution. So 40% ethanol, that will give us 40 grams of ethanol. So if the solution have 40% ethyl alcohol, that means the water there would be 60% with a total of 100%. Okay? So 40 grams of ethanol times, this is now the molar mass. In 1 mole of ethanol, there are 46 grams of ethanol. Why we did not put 46 grams on the numerator? If we put it there, we cannot cancel the grams ethanol. We need to cancel gram ethanol, so that the unit left would be mole, which is what we need. Okay, so grams ethanol cancelled. 40 times 1 is 40, divided by 46 is 0.87 mole of ethanol. Mole of water, 60 grams of water times, again, 1 mole of water is equal to 18 grams. So 1 mole of water is equal to 18 grams of water. Gram water, cancelled. What is left is mole water. 60 times 160 divided by 18 is equal to 3.33 moles. So we have now the number of moles. So we now solve for the mole fraction. Mole fraction of ethanol would be equal to mole of ethanol, which is 8.87 mole of ethanol, and 3.3 moles of water. Okay, mole ethanol, mole water. So 0.87 divided by 0.87 plus 3.3, that would be equal to 0.21, while the mole fraction of water would be mole of water divided by mole of ethanol plus 3.33 mole of water that would be equal to 0.79. There is no unit for mole fractions. Okay. Sample problem number 2. 0.100 mole of sodium chloride or NaCl is dissolved into 100 grams of pure water. What is the mole fraction of sodium chloride in water? Remember, we always start with the given 0.0100 mole NaCl and 100.0 grams pure water. Required mole fraction of sodium chloride formula the same. We have the formula. Okay. Solution. Convert the mass of water to moles. You will need the molar mass of water. Again, molar mass of water is the same with what we solved earlier. So that would be 18 gram water per mole of water, or 1 mole of water is equal to 18 grams of water. So we will convert the mass of water, which is 100 grams of pure H2O, times, okay, we will use this one to cancel grams water, okay, grams water cancelled. So what is left is mole water. 100 divided by 18 is equal to 5.56 mole water. Next, step 2. Substitute the values obtained in the formula and solve for the mole fraction of the solute sodium chloride and solvent water. Mole fraction of sodium chloride is mole sodium chloride divided by mole of sodium chloride plus mole of water. So that is mole sodium chloride is given here, 0.1, and the mole of water is 5.56. Okay, 0.1 mole of sodium chloride divided by mole of sodium chloride plus mole of water. The answer is 0.018. How about the mole of water? Mole of water, 5.56 divided by mole of solute and solvent, 5.66, is equal to 0.982. 5.66 class is 5.66 is equal to 5.56 plus 0.1, that is equal to 5.66. Okay, so these are the mole fraction of sodium chloride and mole fraction of water. If you add this up, it will be equal to 1. Okay. Molality, symbolized by small letter m, is the ratio of the number of moles of solute per kilogram of solvent. It is not the same as molarity, even if their names are very similar. In molarity, the number of moles of solute is divided by the volume of the solution in liters. In equation form, molality is equal to moles of solute per kilogram of solvent, or moles of solute over mass in kilogram of solvent. In problems involving molality, additional formulas are sometimes used to get the final answer. One very useful formula is that for density. D is equal to M over V, where D is equal to density, M is equal to mass, and V is equal to volume. Sample problem number 1. What is the molality of a solution containing 0.75 mole of sodium hydroxide and 500 milliliters of water at 25 degrees Celsius? The density of water at 25 degrees Celsius is 1.0 gram per milliliter. Again, start with the given. Remember, the given will be 1 point, required another point, formula another point, and the solution will have 2 points. So the problem will have a total of 5 points. So density of water is equal to 1.0 gram per milliliter. And the volume of water is 500 milliliters. Molar mass of water is equal to 18 gram per mole. You can solve it again if you want, but the 18 gram per mole we already solved that earlier. And then the number of moles of sodium hydroxide is equal to 0.75 mole. Required molality of sodium hydroxide solution. Formula: moles of solute divided by kilogram of solvent, or M, is equal to N solute, that is mole solute, divided by mass of solvent in kilogram. Solution. Step 1. Determine the mass of water using the density formula. Also convert the mass in grams to kilograms. Okay, the formula is D is equal to M over V. So what we need is the M, the mass. So what do we do now is derive the M, or the mass. So we cross multiply. D times V is equal to M, or M is equal to D times V. Okay, so density is equal to 1.0 gram times the volume, which is 500 ml. ml and ml is cancelled. So 1.0 times 500 is equal to 500 grams. And the 500 grams is converted to kilograms. So 500 grams is equal to, in 1 kilogram there are 1,000 grams. Grams and grams cancelled, and what is left is 0.50 kilograms of water. So that is the mass. Next, step 2. Substitute the given data in the formula to solve for molality. M is equal to moles of solute divided by kilogram of solvent. So the moles of solute is 0.75 moles of sodium hydroxide divided by the mass of water in kilogram, which is 0.05, is equal to 1.5 molar, or 1.5 mole of sodium hydroxide per kilogram of water. Sample problem number 2. A solution was prepared by dissolving 17.1 gram of sucrose in 125 grams of water. Find the molar concentration of this solution. Given 17.1 gram of sucrose is the mass of solute, and 125 grams of water is the mass of the solvent. Required molar concentration. Formula: molality is equal to moles of solute over kilogram of solvent. Solution. Step 1. To find molality, you need moles of solute and kilograms of solvent. The given grams of sucrose must be converted to moles. The mass in grams of solvent must be converted to kilograms. And then we will use the periodic table to compute the molar mass of C12H22O11, or you just can use this 342.34. If we round off the atomic masses of the elements, we can get the total of 342 grams per mole. Either way is correct, aside if your teacher have emphasized that not to round off into a whole number the atomic masses of the elements. Okay, so solve for the mole of sucrose is equal to the mass of the sucrose over the molar mass. So 17.1 gram of sucrose times 1 mole of sucrose is equal to 342.34 grams of sucrose, is equal to 0.0500 moles of sucrose. And then we convert the 125 grams water to kilogram. In 1 kilogram there are 1000 grams. Grams water cancelled out, and the final answer would be 0.125 kilogram of water. Step 2. Solve for the molar concentration. Molality of sucrose is equal to mole of sucrose over kilogram of water. So the mole of sucrose is 0.0500 mole divided by 0.125 kilograms of water. So the final answer is equal to 0.400 molality, or mole per kilogram.